Algebra 2, 7.6, we're going to solve radical equations. So what we have here is a couple examples of radicals. Basically the square root things, square roots, cubed roots, fourth roots, and so on. The biggest thing you need to realize is that if you remember that the nth root of x is the same thing as x to the 1 over n power, right? And so if I want to cancel out a root, I'll just use the power of power idea or take something to that power. So if I wanted to get rid of a cubed root, I'll take the third power. If I want to get rid of a fourth root, I'll take the fourth power. If I want to get rid of a square root, I'd square it. So that's what we're going to do for all of our problems. So really, it comes down to isolating the radical, and then you can get rid of it. So in this case, to isolate the cubed root of x, I need to do what?
Third power.
No, I got to isolate it first. So that means there's a cubed root of x minus 4, so I need to add 4 to both sides. So now I have the cubed root of x equals a 4. And now, to get rid of a cubed root, I will take the... it is the 1/3 power right now. So let's take a look at that. This is x to the 1/3 equals 4. Those are equivalent. Think of this. I want to raise it to a power that will allow me, remember what you do to one side, you do to the other. When I bring a power and I have to multiply, what multiplied to 1/3 will cancel it? 3. And then what I do to one side, I have to do to the other, because these will cancel each other, and you're left with x equals 4 to the 3rd power. 4 times 4, 16. 16 times 4? 64. That's what it comes down to in this lesson, is getting the radical by itself, and then doing the reciprocal, there's a better option, the reciprocal power. Okay. Now, we don't necessarily have a radical here. Basically, how do I get rid of an exponent? Okay? And that's where I said earlier that you're going to take the reciprocal power of both sides. But to get that, you still need to isolate the variable that has the exponent on it, which means divide both sides by 2. So we divide by 2, and so these will definitely cancel. X to 3/2 equals 125. So 125. And like I said, to get rid of something to the 3/2 power, you take it to the reciprocal, which would be 2/3 power. Change colors here, so it would be 2/3. But then this side also becomes 2/3. So that's really cool. These will cancel each other out. I got x. That's awesome. But now I have this 125 to the 2/3 power. Now I could take my calculator out and find out if that's nice or not. Or if the fact that, remember that power of power idea, that I could split this up. I could split this, and there's 2 different ways. 125 squared to the 1/3 power, but do you know 125 squared? That's going to be a fairly large number. Or, can I take it as 125 to the 1/3 power, and then eventually square? Which I think everybody can kind of do the cubed root, or what's 125 to the 3rd power, or what times itself 3 times is 125. It's 5. So that means it becomes 5 squared, and 5 squared is 25. So that means what is x? X is equal to 25. No calculator needed. I thought that was pretty good. So now we're going to kick it up a little bit. Now we have a square root, which is not a big deal, but let's square it. But I can't square both sides with that 2 hanging around. I got to isolate it again. The other thing about this problem is that just because there's stuff inside the square root, it will not be affected when I square that side. Just the side that's not having a square root. And so, my first step is definitely to subtract 2 from both sides, so that's gone. I'm left with the square root of 4x minus 7 is equal to 3. Pretty simple, straightforward thing. But now, I have to square both sides. And so when I go to square both sides, the square and the square root cancel, leaving me with whatever's inside. And 3 squared is 9. This is an Algebra 1 problem. Now we just turned it into an Algebra 1 problem where I can solve for x very easily. Which means, add 7. So 4x equals 16, and divide by 4. X equals 4. Now here's the thing. I haven't brought this up yet. Every time we're solving an equation, you're solving for a variable, you better check it. You better plug it back into the original problem, way up top, and make sure it works. Because in the next problem or two, we're going to start talking about what happens if the answer actually doesn't work. So, we good? Okay. Oh, now this one. This is probably one of the hardest problems of the whole entire section, is what happens when there's more than one radical. So that means there's more than one square root, cube root, so forth. The biggest thing on this one is you need to separate. Separate the radicals. Separate them to their own sides. Sometimes it's not just a 0. Sometimes it's like a 2 there. I'm still going to get the other one to the other side. It creates a binomial. You know how to square a binomial. Separate, FOIL, that type of thing. So what we're going to do is I'm going to add 2 square root of x to both sides. So these cancel. And so I have a square root of 3x plus 2 equals 2 square root of x. This problem actually lends itself pretty nicely to the fact that if I want to get rid of this square root, all I have to do is, not square root, but square it. So if I square it, that's fine. Because if I square this side, this square root will go all the way too. But the problem is they got a 2 hanging out front. But remember your rules of exponents, that when you square something that is a product, the 2 gets carried to both pieces, right? So, yes, this side is gone. It's 3x plus 2. But this side becomes 2 squared, 4. And these cancel each other out, x. Pretty straightforward. You now can solve it. Get the 3x to the other side. 2 equals x. Again, check to make sure that it works. Okay, this one is what I was talking about. Make sure you check your answers. So what they're going to have here is they're going to have extraneous solutions. Extraneous solutions are extra solutions. When you square root and you square and cube root and cube things, it kind of produces a lot of different junk sometimes. And you can do everything mathematically correct, and the answers will not work. So, let's check this out. I've got a square root. I don't like square roots. So, you're saying what? What should I do? Square it. This is what I was talking about, that sometimes one of your sides ends up being bigger than just a number. So we're going to have to FOIL that on the left side. I think we should be able to agree that it's going to equal 2x, but that other side is going to equal x minus 4 squared. So, let's just draw it out. That's x minus 4 times x minus 4. Which, FOILing, is x times x, x squared. X times negative 4, negative 4x. Negative 4 times x, another negative 4x. And negative 4 times negative 4 is positive 16. And that all equals 2x. The middles can go together. I do believe you can agree with that, yeah? So x squared minus 8x plus 16 is equal to 2x. Now, to solve something like this, because it's a quadratic, you want to bring everything to one side and then factor. I think the easiest way to do that would be subtract 2x from both sides. So x squared minus 10x plus 16 equals 0. So, are there factors of 16 that can add to a 10? Two and 8. X, 2, x, 8. C is positive, so they both have to be positive or both be negative, but since the middle is negative, they're both going to be negative. Okay. They're set equal to 0 still, right? So if I wanted to solve each one of those separately, I could set that both of them equal to 0. So when does x minus 2 equal 0, or x minus 8 equals 0? It's when x equals 2 and x equals 8. Those are things we've done many, many, many times. So, check them. This is where it's going to be checked. This is why I didn't check all the rest of them, because they did work. But you're like, oh, there's my answers. I'm walking away now. Can't do that here. If I take those and I plug those back up into here, think of 2 minus 4. What's 2 minus 4? What's 2 minus 4? It's negative 2. That should equal, over here, 2 times 2?
4.
And square root it.
Or 2.
Should be 2. Is that true here? Is that true? I just put both sides. Is negative 2 equal to 2? No. So guess what? 2 is not a solution. We did everything mathematically correct, but it doesn't work. Let's check 8 then. 8 minus 4. 4. That should equal 2 times 8.
16.
Square root.
4.
That checks out. So 8 is the only solution. Sometimes 1 will work, sometimes all of them will work, and sometimes none of them will work. But if you think about it, when I put 2 into here, I got a negative. Can you ever square root a number and get a negative? No, because square roots are always positive. So that's why it doesn't work.